Hello everyone, this is Prakhar and today we'll be telling you about
How a simple FM receiver works. This is a block diagram of an FM radio receiver. It basically consists of an antenna, a tuner, and a limiter and a detector. The antenna is that part of the receiver which receives the FM waves from the air. A tuner decides which frequency FM waves we want to receive. A limiter helps in removing the distortion that may be present in the received waves. And finally, a detector. It is this part that converts the waves.
start करें.
Linear circuit is simply and we have the input waveform with a variable amplitude variation. But we need waveform with constant amplitude variation. And the limiter, the function of limiter is to remove these distortions. So now I will explain about the working of limiter. For positive input voltage signal, when input voltage exceeds battery voltage plus V1, which can be adjusted by the potentiometer. Diode D1 conducts heavily while diode D2 is reverse biased, and so voltage plus V1 appears across the node. This output voltage plus V1 stays as long as the input signal voltage exceeds plus V1. Now we come to the negative input voltage signal. So for the negative input voltage signal, the diode D1 remains reverse biased and diode D2 conducts heavily only when input voltage exceeds battery voltage V1 in magnitude. Thus, during the negative half cycle, the output stays as minus V1 so long as the input signal voltage is greater than minus V2. And finally, we achieve the desired output waveform.
I'll be talking about the detector. The detector is a very important part of an FM receiver because it converts the frequency modulated wave back to the analog. It is this analog wave that carries the message. The detector that I'll be talking about is a very simple and a basic slope detector. According to the principle of the slope detector, the received FM signal is applied to an LC circuit and will also modulated signal. This signal is then passed to an aim detector which uses a detector diode D to recover the modulating signal B naught. The circuit diagram of a slope detector is shown. This circuit is known as a single tone slope detector. The transformer T passes the received signal to the diode D. The secondary winding of the transformer T, used as the inductor and a capacitor CT, are connected to constitute an LC resonating circuit. The secondary winding is tuned to a frequency slightly less than the resonating frequency of the LC resonating circuit. F0 is greater than the central frequency of the input signal FC. If the maximum frequency deviation in the input FM signal is plus minus del F, the operating frequency range of the voltage versus frequency curve will be Fc minus Fd to Fc plus Fd, as clearly shown. This range covers the linear region of the curve. The frequency variation is converted into the corresponding voltage variation, and the voltage available at the anode of the diode D carries both the amplitude variation and the frequency variation in direct proportion to the modulating signal. This is marked as V0. The detector diode D rectifies the secondary voltage VD, which is marked as RD. The rectified voltage is used to charge the capacitor C up to the rate values. The capacitor discharges through the resistance R to develop the modulating voltage V0. This modulating voltage is the voltage marked in figure A. As a result, the slope detector circuit calculates the received signal and recovers the original modulating signal. That receives radio frequency transmissions like radio broadcasts and converts selected carrier frequency and its associated bandwidth into a fixed frequency that is suitable for further processing. The word tuning in radio context means adjusting the radio receiver to receive the desired radio signal carrier frequency that a particular radio station uses. The simplest consists of the inductor and the capacitor connected in parallel, where the capacitor or inductor is made to be variable. This creates a resonant circuit which responds to an alternating current at one frequency. Combined with a detector, also known as a demodulator, it becomes the simplest radio receiver, often called a crystal set. Practical radio tuners use super heterodyne receiver. Older models would realize manual tuning by means of mechanically operated ganked variable capacitors. Often, several sections would be provided on a tuning capacitor to tune several stages of the receiver in turn or to allow switching between different frequency bands. A later method used a potentiometer supplying a variable voltage to the raptor diodes in the local oscillator and tank circuits of front-end tuner for electronic tuning. Still later, phase locked loop methods were used with microprocessor control. The broadcast audio FM band is around 100 times higher in frequency than the AM band and provides enough space for a bandwidth of 50 kHz.
So
Now,
how
how
to
to
get
get
93.5 megahertz channel on my radio? So basically it is an LC oscillator circuit and its frequency is related to LNC as 1 upon 2 pi root LC. The frequency can be made to 93.5 megahertz by changing either the inductor value or the capacitor value. So the as the capacitor is variable here, on changing the capacitor value to a fixed value, we can make the frequency to 93.5 megahertz. So that's your each of the components explained separately. Now this is how a FM receiver circuit, full FM receiver circuit looks like. This is the part that's coming from the tuner circuit. This is the limiter circuit, and this is the discriminator, or basically the demodulator or the detector part. Now from here, the analog signal goes to the speaker. So that's your FM receiver circuit for you. Thanks a lot, and please like our video and do subscribe our channel for more videos. Thank you.